you, sir. Namaskar, greetings of the day. My name is Devyansh. I'll be presenting on behalf of my team. My team consists of 4 students and 1 faculty mentor. My name is Devyansh. The other authors along with me are Vanshika Bansal, together Mahesh, Galrani, and Gautam Gogia. Under the guidance of Dr. Sudhir Chaturvedi, we took up the project of studying about the evolution of F18 Hornet, which has recently been proposed by Boeing for the Indian Navy. So before we begin, I'd like to say that the Indian Navy has recently inducted its first indigenous aircraft carrier, the INS Vikrant, for which they are looking for options to procure certain aircrafts. So for that, we started to study this particular system. So F-18 Hornet, it's basically an all-weather twin-engine supersonic carrier-capable multi-role combat aircraft, designed both as a fighter and an attack aircraft. That is why it has the designation of F/A. Now, when we look about how this aircraft came into existence, um, the United States of America had launched a Air Force lightweight fighter technology evolution program, where multiple contenders, multiple aerospace companies had given out their designs. And out of which the McDonnell Douglas and Northrop had partnered and given us the YF-17 in the 1970s for the use of United States Navy and Marine Corps. So let's look at the YF-17. It was a prototype. It was a lightweight fighter aircraft designed by the Northrop Aviation for the United States. And this in this initiative, many fighters had come up, many fighter aircrafts had come up, and people believed that the aircraft like the F-15 were too large and expensive for various combat roles. That is why the US Navy felt, or you can say the US Air Force, felt the need of a lightweight fighter aircraft. However, the Northrop YF-17 lost the LWF competition to the F-16 Fighting Falcon. This particular, you can say, platform was selected for the United States Navy in order to complement the more expensive F-14 Tomcat. And as you know, eventually the United States Navy decommissioned the F-14 and opted for an entire fleet of a F-18 based aircraft. So the design, it is conceived as a very small and lightweight fighter, and it was scaled up to the Boeing F-18E and F Super Hornet variants, which are similar in size and weight to F-15, and they eventually replaced the F-14. If you look at the general characteristics of this particular aircraft, it had a one-member crew. It had a wingspan of 35 feet and a total wing area of 350 square feet, with a power plant of General Electric Y101 G100 turbojet. When we look at the armament which this aircraft was able to carry, it was just a single gun with 2 missiles, AIM-9 Sidewinders, which are Fox 2s, basically heat-seeking missiles. So this was just a prototype, and this particular aircraft became the base for the upcoming variants of FA-18. When we look at the FA-18A and B variant, which is referred to as the Classic Hornet, the F-18A was a single-seat variant, and it was able to employ the air-to-ground missile 84 Harpoon, AGM-65E Maverick, and the HARM and Walleye variants of various missiles. All of these were the air-to-ground missiles, which this particular aircraft was able to carry. The major evolution which happened was that this particular aircraft was able to, came equipped with the AN/AS-38 Nighthawk targeting pod, which was basically a laser spot tracker, and it was essentially used for targeting various, you can say, targets. Now, the F-18B variant, it had the space for 2-seat cockpit, but for which what the designers had done was that they had relocated a lot of avionics equipment, and they had reduced the internal fuel capacity by 6%. The 2-seater Hornet was essentially fully capable of combat, but the B model was primarily used for training. When we talk about the further enhancement, then in the 1992, the original AN APG-65 radar was replaced by Hughes, which is now referred to as Raytheon Technologies, AN APG-73 radar, which was basically a more faster and a more capable radar. Capable here refers to the range of it. The A model Hornets that had been upgraded with the 73 were now capable of carrying AIM-120 AMRAAMs, which are essentially the active radar missiles, active radar and air-to-air missiles. And this particular you can say variant was it had been started to refer to as F18A plus. Then we came to the C variant, the Legacy Hornet, commonly known as. Now, this particular aircraft is the one aircraft which has seen active deployment in various operations taken up by the United States Navy and the United States Marine Corps. The F-18C was a single variant and the D was a two variant. The D model could be configured for training as well as an all-weather strike aircraft. The missionized D model's rear seat is basically configured for a weapon systems officer. And the F-18D was primarily operated by the United States Marine Corps in the night attack and forward air controller, or you can say FACA roles, that is the airborne forward air controller. The C and D models are a result of a major block upgrade in the 1987, incorporating the upgraded radars, avionics suite, and the capacity to carry the new variants of the AIM-120 AMRAAM missiles. Later on, they even incorporated the AGM-84 E-SLAM as well as the IR version of the AGM-65 and 65F. Other major, you can say, upgrades had included the Martin Baker NACES, that is Navy Air Crew Common Ejection Seat, and a self-protection jammer. In all, they made the F-18C and D variant a completely capable aircraft, able to undertake multi-role operations effectively. The C and D models delivered after the 1989 also had improved night attack abilities. It basically consisted of AN/AR-50 thermal navigation pod, AN/AAS-38A Nighthawk FLIR, which is called as the forward-looking infrared array targeting pod, night vision goggles, and two full color. Formerly, they were monochrome displays. Now they were upgraded to full color multifunctional displays and a color moving map. The D variant, like in addition to these two variants, 60 of the D models were configured as night attack reconnaissance models. These were basically the aircrafts which were outfitted with ATAR's electro-optical sensor package that included a sensor pod and equipment mounted in the place of the M61 cannon. In the name of further enhancement, in the beginning of 1992, the General Electric F404 enhanced performance engine, they had basically put that up, and it had been providing approximately 10% more maximum static thrust, and that became the standard Hornet engine. In 1993, AAS-38A Nighthawk added a designator ranger laser, allowing it to self-mark targets. The later AAS-38B added the ability to strike targets designated by laser from other aircrafts. The last legend, or so as to speak, when the production of C and D models had come to an end in 2000, the last F-18 was assembled in Finland and delivered to the Finnish Air Force in August 2000. When we talk about the general characteristics of the F-18C and D variant, depending upon the variant, the crew can be switched. Like for the C variant, the crew is 1. For D variant, the crew is 2. The wingspan of the aircraft is 40 feet 4 inches, giving it a total wing area of 410 square feet. Power plant is the 2X General Electric F404, F402 afterburning turbofan engines, as mentioned, which are providing a 49 kilonewton of thrust on dry and 79.0 kilonewton of thrust with afterburners. The basic armament of this includes 9 hard points, 1 gun, which is the Vulcan nose mounted gun, 6-barrel rotary cannon, along with certain different air-to-air missiles and air-to-surface missiles. It also had the ability to carry various different pods, such as the ADM-141 TAL pod, the SU-42A infrared decoy dispenser. It had the ability to carry the ECM pod or the targeting pods as well. In terms of avionics, the major upgrade was the Hughes ATG-73 radar. They had updated the radar RWR characteristics, which is the radar warning and receiver characteristics, by putting in the ALR67. They also had put in the remotely operated video enhancement receiver antenna for use by the US Navy's F18C strike fighter squadrons. So the legacy Hornet had then eventually evolved into the final variant, which is referred to as the Super Hornet. The Super Hornet, as I mentioned, is the E and F variant, E being for single-seater and F being for the two-seater variant. They were both officially named as the Super Hornet. And now the major difference was in the overall airframe. When we talk about the legacy Hornet and the Super Hornet, the Super Hornet had a 25% larger airframe. The air intakes were reconfigured into a rectangular design, and the engines were also replaced. They had a more capable GE F414 engines, along with a major upgrade in the avionics suite. This particular variant is commonly referred to as the Rhino variant in operational use. When we talk about the general characteristics, the wingspan of the aircraft was increased to 44 feet 8.5 inches, which eventually increased the wing area to 500 square feet. When we talk about the overall thrust given by the engines, it is 58 kilonewton by each in dry configuration, and with afterburners, it's 98 kilonewton. The armaments which this particular aircraft is able to carry is that with increase in the overall structure of the wing area, they had introduced 2 new hard points, 2 at the wingtips, 6 under wing, and 3 under the fuselage. When we talk about the maximum payload carrying capacity, the maximum payload carrying capacity of the A variant has increased to 17,750 pounds. And it is capable of having a lot of different aircrafts. Now, we have now the reason we took up this project was pretty simple. We wanted to give a suggestion to the Indian Navy whether they should buy the F18 Hornet or not. As I mentioned earlier, that INS Vikrant has recently been inducted, and that particular aircraft carrier is not a conventional one. The United States have what is a catapult-based aircraft carrier. We, on the other hand, have a ski ramp-based catapult carrier. Just give me a minute. It looks something like this. So, using a simulator called as DCS, we have a mock-up of the INS Vikrant. And as you can see, there's no catapult over here. We only have 2 runways, shorter runway and longer runway for cyclic operations. So, and what we have here is the C variant with us, C variant of the F-18 Hornet. And we are today doing trials on the ski ramp based on the ground. The configuration which we have selected for this particular trial is full air-to-air configuration. This is the C variant along with the full air-to-air configuration, and the overall weight is near about I'll have to check that. I am just give me a minute. I'll take the overall weight. So the overall weight right now is at 45,500 pounds, and we'll just provide the aircraft with the full afterburners, and we'll try to get the aircraft to take off from the ski. We'll pull on the stick. As you can see, the aircraft speed is increasing, and we will try to maintain the angle of attack. But as you can see that this particular aircraft is able to sustain the flight, but the pilot has to give a lot of input, and eventually we crash. That makes the integration of this particular aircraft a little bit tough onto, I guess I'll have to eject. This makes the integration of the F18 aircraft a little bit tough onto the aircraft carriers, which I'll show you a couple of videos as well. These are the pre-recorded videos which I took of the.
You need to conclude the presentation, okay?
So what we have basically done is we have the mock-up of it. It takes a lot of time to reload. So this is the mock-up of the INS Vikrant, and the aircraft will attempt to take off. This is in the no payload category. That is that the aircraft is having absolutely zero payload. No external weight is there. And even in that condition, the aircraft is barely managing to take off, making this particular variant or this particular airframe not suitable for a ski ramp based aircraft carrier. So I'd like to conclude that the Indian Navy should wait for the Aeronautical Development Agency and Hindustan Aeronautics Limited to provide better clarity on the upcoming twin-engine deck-based fighter project. And even if they end up signing a deal with Boeing, they should buy all the three variants, which are the E, F, and G variant. When we talk about the G variant, it is nothing but the electronic warfare capable variant, and that is where presently, with respect to the arsenal which India has, we currently do not have a dedicated fighter aircraft capable of electronic warfare. So even if we end up buying from Boeing, we should opt for the three variants, that is the E, F, and G variant, in order to fulfill the presence of a dedicated electronic warfare capable fighter, along with the complete package for performing a wide range of missions with minimum resources. Moving on to the acknowledgement, we'd like to thank the US Chief of Naval Operations and the Commander of Naval Air Systems Command for releasing their official NATOPS flight manual for the general public. We'd like to thank Eagle Dynamics for creating one of the most realistic combat flight simulator available to the general public. And we are highly indebted to Dr. Sudhir Chaturvedi for allowing us to pursue this project and contribute our level best towards the defense of Indian airspace. Thank you. Jai Hind.